So in this example, we are going to be modeling a linear equation. And it reads, at a local movie theater, the cost of a ticket for a Saturday afternoon matinee movie is $7 for an adult ticket and $3.50 for a child ticket. The total ticket revenue for one particular Saturday afternoon was $3,619. So then we have these three questions here. The first one says, write the linear equation where the price of a child ticket is a function of the total ticket revenue for this Saturday afternoon matinee. So, of course, we're going to be doing a linear equation. So we want to come up with a linear equation that's going to replicate or model this scenario here. So let me point out a couple of things. It says at a local movie theater, the cost of a ticket for a Saturday afternoon matinee, that's $7 for an adult ticket, and it's $3.50 for a child ticket. It also says that the total was $3,619. So I'm going to let A, how about if we let A equal to an adult ticket? That's going to be my variable. And we'll let C equal a child ticket. So I do know that for a total, if I add all the adult tickets together with all the child tickets, it's going to come out to be $3,619. However, it's $7 an adult ticket and $3.50 for a child ticket. So as a linear equation, I guess we could write it as 7a plus 3.5 or 3.5c. That's going to equal to 3,619. And as you can see, this is in standard form. ax plus by is equal to c, except we're using a and c rather than x and y. So this is the linear equation that models this scenario. Now A, we'll reread A. It says write the linear equation, that's this one here. Write the linear equation where the price of a child ticket is a function of the total. So since the child ticket is a function, the child ticket is the dependent ticket. It depends upon what the function is going to do. So since this is a dependent ticket, it depends upon A. So we're going to write our equation here in terms of the child ticket. So we're going to wind up writing this rather than in standard form. We're going to write it in slope-intercept form, except rather than using x and y, we're using a and c. So what we can do is I'm going to subtract out 7a. That leaves us with 3.5c. That's equal to negative 7a plus 3,619. We can then divide out the 3.5 from either side, or go ahead and multiply the entire thing by 1 over 3.5. 1 over 3.5 times 3.5c, of course, leaves us with c. Negative 7a times 1.1 over 3.5, that leaves us with negative 2a. And 3,619 divided by 3.5, that leaves us with 1,034. And as you can see, it looks similar or just like a slope-intercept. So since the child ticket is a function of the total, it's a function of A, then we can say that C is going to be equal to f of A. So then we can write this as f of A. That's equal to negative 2a plus 1,034. So write the linear equation where the price of a child ticket is a function of the total ticket revenue for this Saturday afternoon matinee. That's going to be f of A. That's equal to negative 2a plus 1,034. So then it says, what is the slope? Well, the slope is negative 2, right? So we can say the slope, m, is negative 2. What is the y-intercept? The y-intercept is 1,034. So we could say that b, that's our y-intercept, is equal to 1,034. B then says if 256 adult tickets were sold, how many child tickets were sold? So we're going to use our function. F of the adult tickets, A, that's 256. F of 256, and we've learned before in functions, that means negative 2 times 256 plus 1,034. We're just using our function. Negative 2 times 256, that's negative 512 plus 1,034. Negative 512 plus 1,034. 522 child tickets were sold. So if 256 adult tickets were sold, that means 522 child tickets were sold. So this is 522. And you could certainly check that by slugging it into here. 7 times 256 plus 3.5 times 522 should equal to 3,619. Now C says if 672 child tickets were sold, how many adult tickets were sold? Well, child tickets, if this is 672, right, here's our child ticket, C. If this is 672, then I can write this as 672 is equal to negative 2a plus the 1,034. And then just solve for a, because that's what we want to know, how many adult tickets were sold. So we could go ahead and we could subtract out the 1,034. $672 minus 1,034. That's negative 362. That's equal to negative 2a. And then we can divide both sides by negative 2. Therefore, A is equal to 181. So if 672 child tickets were sold, how many adult tickets were sold? 181. And we could check it again. We could put in 7 times A, which is 181, plus 3.5 C, which is 672. That should come out to be 3,619. And there we go.